Hi there, everybody. My name is Devin Bruce, and I'm the instructor for this semester's History of Photography Photo 420 course. This is an 8-week accelerated course, and it's the equivalent of a full 16-week semester that's been compressed into half the time. The pacing of this class is pretty robust. It's 2 weeks of material that opens up every single week for you. To give you a little bit about myself, a little information, my name is Devin Bruce. Like I said, I am a professional photographer and I also teach photography. I've done photography for about 30 years now, and my past photography experience has included commercial photography, portrait photography, editorial photography. I was freelance photography for a long time. I became a writer as well for magazines and newspapers. I managed commercial space. I ran one of the most busy portrait studios in Northern California for a number of years. And now I devote myself full time to teaching. I'm really excited for this course. The history of photography is amazing, and every time I pick up the book, I learn more and more stuff, or I'm reminded about more and more stuff. I'm really excited to share that with you. That being said, I want to talk to you about the class really quickly before we jump into it. It is so important for you to jump into the syllabus and take a look at it, and make sure whether you print it, you write it out, you have it saved on your desktop so you can reference it when you need to. It's going to have like the keys to what's going on in class. It's going to have the assignments that we're going to be doing. It explains the depth of some of the assignments. And I will, through that and the Canvas shell, the Canvas course, be explaining to you week by week what assignments will be due and what's coming up. The students that do well in this class are the ones who watch the lecture recordings, and they also do the readings early on each week. There's a Thursday deadline for one of the assignments for the journal discussion, and I will go into that with you later on in this Canvas course for this week. But you want to make sure that you have the reading and the watching the lecture done well before that, so that you can be able to participate fully. Remember that falling 1 week behind in an 8-week course is the same as falling 2 weeks behind in a regular semester course. It's very easy, it can roll out of control. I tried to design this course to be a substantive, and to treat you as capable of serious thinking about serious material. If you hit difficulty, please reach out to me. You can get me through email, or you can get me through the inbox here in Canvas. And please don't try to do it the night before something is due. If something comes up and you know about it, please, the sooner you can let me know, the better. One thing I will caution you about that you really need to do is invest in a notebook. I'm a big believer in having a physical notebook so that you can sit next to it, and while you're reading, you can jot notes into it by hand. Some people prefer to do using the computer. I'm a big believer in actually writing it down, physically writing it down yourself. It helps with retention, and also a lot of times while you're writing, it helps to clarify a little bit. While you're writing, you are thinking about how you're writing and what you're going to put out there, and it helps refine sort of what you're thinking about. When you're taking your notes, during the reading, for example, as you're reading, jot down some things, some factoids, but also think about questions you may want to ask, observations that you have. It doesn't have to be just copying what's from the book onto your notebook. We will also be referencing, I'll have you stopping and doing some small writing exercises to try to develop your thinking about some of the topics going on. So having that physical notebook is very important. So let's get started. Speaking of your notebooks, let's take a few minutes at the very beginning to do this here. I'd like you to pause. So go ahead and pause the video after I tell you what to do. I want you to pause the video and set a timer for 3 minutes. And I want you to think about the question, what is a photograph? Think about it. It doesn't have to be right or wrong. There is no right or wrong answer right now. I want to know what your perception of a photograph is. And I do want you to write it down into your notebook, and I want you to save it. Circle it. Hopefully be one of the very first things in the notebook. I want you to do this because we are going to come back to this in week 8 and see how you felt about what a photograph is now compared to what it is then. The goal for it is not to have a correct answer. There is no correct answer yet at all. The goal is to surface the assumptions that you bring to the course before the material has a chance to complicate them. Most students will write something about cameras, lights, and captured moments, but by week 8, I can guarantee that your answer will look very different. So go ahead and pause for 3 minutes and write down your thoughts or feelings about what a photograph is. And then when you're done with the 3 minutes, go ahead and continue on. The author Robert Hirsch opens our book, Seizing the Light, not with a daguerre, but with a claim. The claim is that photography was not invented in a vacuum. It was demanded. Multiple inventors in multiple countries were working on it simultaneously because the socio and economic conditions of modernity had created a need for it. So what were those conditions? There were many conditions, such as trade and commerce needing accurate, portable visual records of goods, buildings, and landscapes. Science needed reproducible visual documentation of specimens, geographical surveys, and astronomical observations. The press needed images that could be reproduced and distributed to mass audiences. Empire and colonialism needed tools to document, survey, and control the populations. And the emerging middle class wanted portrait images that previously only the wealthy could afford to commission. One key point is that photography was not invented and then adopted. It was demanded and then invented. Multiple inventors in multiple countries were working on it simultaneously because the social and economic conditions of modernity had created a need for it. This is one of the most important areas and ideas in Hirsch's Chapter 1, and this idea will reoccur throughout the course whenever we ask why a new form of photography emerged, when and where it did. The camera obscura, which means dark room in Latin, is a room, tent, or box with a small hole in one end, much like this right here. Light from this scene outside passes through the hole and projects an inverted image on the opposite wall. Artists used portable camera obscuras as drawing aids from at least the 16th century. In this one here, this is one that was more room size that was built, and it was considered portable, but they would set it up. And remember, there's no empty wall here. It's a fourth wall. We're using our imaginations to peek through it. But in this dark room, with the hole poked in the wall there, light bounces off of the subjects, or what they're wanting to draw or paint, passes through that hole, and then displays inverted on the wall there. Giovanni Battista del Porte, an Italian scholar and polymath, described the camera obscura in detail in 1558, and the astronomer Johann Kepler actually coined the term camera obscura in 1604. Now, of course, having a portable room that you build whenever you need to draw or sketch something wasn't very practical. And as they understood more of what was happening, and they started to have things like refined glass, they started making lenses. And by the 18th century, portable box versions of the camera obscura were widely used by landscape and portrait painters. With this kind, like the one below, light would enter through a glass lens and then reflect onto a mirror that was bent at a 45-degree angle. Figure M on that picture, I believe. M for mirror, I guess. That mirror would bounce the light and image upwards, where it was projected onto a piece of ground glass from underneath. It sort of works the same way that a periscope works in a submarine, or even how the lens works in your digital lens or your DSLR. So that way you can see what's coming through the lens through the viewfinder. Well, with these, it projects the image from below onto a piece of ground glass, and when the image hits it, it displays, and the artist would then put a piece of paper on top and trace what they see. So Vermeer, the painter of the famous girl with a pearl earring, almost certainly used a camera obscura in his work. In this painting that you see that Vermeer made, titled The Art of Painting, there are clues that a camera obscura was used in his creation. People have noticed the exceptionally realistic perspectives and its highly accurate rendering of spatial relationships. For instance, the maps on the wall, this painting here, are very, very highly detailed and reproduced almost exactly how those maps are in real life.
I'm standing in the studio space of the Oranda studio floor, which is the third floor of the Photographers Gallery in London, and I'm going to demonstrate the camera obscura. Most of us think of a camera as a device for taking pictures, but camera in Latin actually means room, and camera obscura means darkened room or chamber. It's quite simple to create a camera obscura. If you make a hole or an aperture in the exterior wall of a building or room, light filters through that hole or aperture into the space, and if the space is dark, what you'll see is an upside down and inverted image of the scene outside. Like many publicly accessible camera obscuras, our camera obscura has a lens and a mirror. The mirror sits in a turret and allows us to rotate the scene using a wheel. The earliest mention of a camera obscura is said to be by the Chinese philosopher Mo Ti in the 5th century BC. The Greek mathematician Euclid is said to have used a camera obscura in the 3rd century BC to prove how light travels in straight lines. Over 1,000 years later, the Arab scholar Al-Hasan used several lamps to demonstrate that what was being projected into the darkened room was an inverted image of the scene beyond the aperture. Johannes Kepler in the 17th century, an astronomer and mathematician, was able to draw connections between the camera and the human eye. Also in the 17th century, it has been suggested that the Dutch painter Johannes Vermeer used a camera obscura as an aid to his painting. Many artists use portable camera obscuras to make their work. More recently, Victorians used the camera obscura as a form of entertainment. This is the camera obscura in Aberystwyth, Wales. The lens and mirror project the image onto a viewing table inside the camera. Our camera obscura offers a 360-degree view from Great Marlborough Street, along Ramilly Street, over to Oxford Street and to the sky. This camera obscura has a movable screen, which you can position to capture the image. The far distance will find its focus point on the screen closer to the lens of the camera, around the middle of the room. Scenes closer to the lens outside, like the street below, will find their focal point toward the back of the room. Depth of field can be demonstrated by moving the screen. The Photographers Gallery invites visitors to come and explore our camera obscura for themselves.
My name is Robert Tacchetto. I'm the operator of the camera obscura, and I've been operating it since 1995. And it's a beautiful experience, and everyone should come down here. We're at Ocean Beach, located behind the Cliff House on the lower terrace. I encountered it when I was 10 years old. I used to sneak in here all the time. I used to just hang out down here and go get an is-it, run up here, and sneak in with my bathing suit. It was like a different image, so it was like something in a bowl. So that was kind of spectacular, that itself. It was great because every time I can just sit back there and look at the seal rock and Ocean Beach and all the seals. This was built in 1946. It was built by Floyd Jennings. In 1956, it was later changed to a camera look here because people didn't know what a camera obscura was. So the owner, Mr. Whitney's Jr., recommended it look like a camera. It's the principle of light hitting a pinhole. So the light rays crisscross and the image is formed in a dark room. And this one here is called a pyramid camera obscura, where the image comes down. And it's best compared to an eye because the image is produced on a large concave table.
Hey, Robert,
Yes?
take it back up again.
There's an eye on top of the pyramid that's rotating, and that's a symbol of the cosmic eye, seeing everything. Well, that's my interpretation. The table's evenly focused. Up or down is how you focus it, so everything in the camera is focused for 100 meters. And then it rotates 360, so everything you see outside, you'll see inside. And the colors are a little more subtle, so it gives that little painting look. It looks like a pastel colors. So it's very beautiful. That's why it's even better inside than outside.
Beyond the blue horizon waits a beautiful day. Goodbye to things that bore me. Joy is waiting for me. I see.
The camera obscura changes my perspective in a way because you see things in a different way. It's the same lighting from outside, but what happens when it hits a pinhole and gets captured in the dark room? It produces a different perspective of everything. So that's what makes it so special.
The camera obscura solved the problem of projecting an accurate image of the world. What it could not do was save it. It could project the world, but it could not keep it. The question that drove photography's inventors was a simple one. How do you keep the picture? We're going to take some time to investigate the pre-photographic tradition and the key figures in it. The first one was Thomas Wedgwood. So Wedgwood was the son of a famous English potter named Josiah Wedgwood, and actually Wedgwood pottery and ceramics are world famous even today. And Thomas was the first person to systematically experiment with the chemical action of light on silver salts. He was able to create cameraless silhouettes by placing objects on silver nitrate paper and exposing them to sunlight. But he could not fix the images. They would darken completely if taken into the light. He ended up publishing his results in 1802, but they were not reproducible. Wedgwood is important not as the inventor of photography, but as the person who identified the correct chemistry and the correct problem: permanence. He just could not solve it himself. So in our text, Hirsch covers several different other figures in Chapter 1 who contributed to photography's prehistory. It is worth naming them briefly here because the standard narrative centers around three other photographers that we'll touch base on in just a few minutes, and these folks tend to be ignored and or erased. The first is Hercules Florence. It was Brazil, 1833, independently developed a photographic process using sunlight and silver nitrate, and this process was largely unknown in Europe at that time. Hippolyte Bayard. That was somebody who was developing a direct positive paper process simultaneously with Daguerre and Talbot. Unfortunately, Daguerre was preferred by the French government because of connections and beat him out barely because of the connections in the French government. Mungo Ponton from Scotland discovered potassium dichromate as a light-sensitive compound, and that contributed later to photomechanical printing. And then Anna Atkins. Now, Anna Atkins is a fantastic, amazing story. She used Herschel's cyanotype process to create the first photographically illustrated book called British Algae in 1843. She's one of the very first female photographers, and she created the world's first photo book. On the next slide, you're going to see a small mini documentary about her. It's absolutely fascinating. Please take a look. And know that this one, the cyanotype process, is one of the ones that we can choose from for our historical processes assignment that's coming up later in this semester. So please take a look and take some notes.
These enticing images were produced by Anna Atkins, one of photography's pioneers, using the cyanotype process, which produces vivid blue tones. Atkins used the process to document various species of algae that could be found across Britain, and over the course of 10 years, Atkins produced 12 volumes of her book, Photographs of British Algae. These algae specimens, which had been scarcely studied at the time, were recorded with groundbreaking accuracy and were the first images to be published as a photographically illustrated book. Through photography, Atkins was able to take something as ordinary as seaweed and transform it into an electric blue library of intriguing forms and shapes. Some appear as shocks of lightning or clouds gathering across a blue sky, whilst others take on ghostly, transient forms, disappearing into the page before your very eyes.
What's so amazing about the cyanotype process is that it has a low bar of entry for folks. You don't need to be very technical minded. You don't need to know a lot about photography in order to produce and create these beautiful images. I have a video following this, though. This is how I was introduced to cyanotype more than just doing photogram type work like this. This photographer and this collector of strange lenses, his name is Matthew Stern. I was introduced to the idea of using cyanotype for portrait photography, excuse me, or more along the lines of not photography, but making portrait prints using the cyanotype process by this video right here. And I did want to share with you, because this is a possibility for one of the historical processes that we can do. So I wanted to show you that you can do more than just what Anna Atkins did with the British algae, as the gentleman was pronouncing it as. But there is more that you can do with it. So I wanted to share this with you really quickly. Okay, everybody, notebook time. Let's take a couple moments and stop and start thinking about some of these bigger questions about photography at this time period. One of the big ones is, why were multiple inventors working on the same exact problem at the same time? Let's think about what this tells us about the relationship between technology and culture at this point in the human history, and what social or economic pressures were creating a demand for this kind of photography before it even existed. These are essential questions that run through the entirety of this course. So keep this in mind as we move forward. But for just a couple of minutes, just jot down some ideas, some observations that you may have made so far. Oh, before you put your notebooks away, though, we have one more thing for you. Here are some key terms that you will want to try to keep in mind as we go forward. Now, some of these terms will not only appear in the lectures, but also through the text that you'll end up reading from here on out. Feel free to take a quick moment or two just to jot down these terms and a quick definition before continuing on. All right. So from this point, we're going to move into the invention of photography. And this portion will be covered in both chapters 2 and 3 in the textbook Seizing the Light. What I would like you to do right now is just take a few moments to examine this image. Really take a hard look at it. And when you're ready, go ahead and go on to the next slide. So, what exactly are we looking at? What do you think this is? When do you think it was made? And what's strange about this? So go ahead and just write down an answer before moving forward. What we have here is the oldest surviving photograph made by Joseph Niepce in approximately 1826 to 1827 in France. And this image required an exposure of at least several hours and possibly longer. The light appears to come from both sides of this image because the sun moved across the sky during the exposure, and that's how we can tell that it was such a long time for it to be able to be produced. The name of this image is View from the Window at La Grasse. Niepce was a French inventor who had been experimenting with lithography and image reproduction since around 1816. For this image, in this experiment, he coated pewter plates with the bitumen of Judea, which is a naturally occurring asphalt that hardens when exposed to light. By exposing a camera obscura image onto the coated plate for an extended period of time, he achieved a permanent photographic record, a process that he termed heliography. So this heliography, which literally means sunwriting, was not very practical for what a lot of people would want to use this for later on. The exposure time for it took many hours to many days, which made things like portraiture completely impossible. And the result of this was a unique, non-reproducible positive image that had very limited tonal range. Niepce proved that photography was possible, but he was not necessarily the inventor of modern photography. He did, in fact, though, prove that it could exist. He actually made a partnership. He formed a partnership agreement in 1829 with another inventor who was actually working on a different process for capturing images at the exact same time. And this person's name was Louis Daguerre. And unfortunately, Niepce died in 1833 before the invention of photography was finally publicly announced. So I enlarged both of these so you could take a better look at it. The one on the right is the one that you typically see in textbooks. It's the enhanced image that sort of shows the buildings, the trees, the horizon of the image. The one you see on the left is how it actually looks. This is the one that's, at this point, almost 200 years old or so, and this is how it looks today. It currently is still developing, and where it's being held at, it's in a light-tight box or airtight box with UV resistant glass to try to slow down the effects of its continual development. Eventually, some people think that it will end up turning black one day. So, we have the pictures to remember it, but until then, we just sort of try to appreciate for what it is. And using my master skills of Photoshop, I created this GIF so you can see sort of where it lines up between what we have with the enhanced version and where it lands on the actual how it looks today version on the computer. Louis Daguerre. This guy's name is Louis Daguerre, and here he is posing for a photo using the very process that he invented and refined, called the daguerreotype. So who was Daguerre? Louis-Jacques Daguerre was already famous before photography. He was the creator of something called the diorama, a theatrical spectacle using large painted translucent screens and that manipulated lighting to create the illusion of movement and atmosphere. He was, in other words, already in the business of creating immersive visual illusions for public audiences. He'd been experimenting with light-sensitive silver surfaces in the 1820s, eventually making contact with Niepce and forming their partnership. However, after Niepce's death, Daguerre continued his experiments and made a crucial discovery, possibly by accident, involving mercury vapor. According to a story, whose exact truth is uncertain, Daguerre placed an exposed but underdeveloped silver iodide plate in a storage cabinet alongside some laboratory chemicals. Coming back the next day, he found that a previously invisible image had developed. Mercury vapor from a broken thermometer was likely the cause. This was the key breakthrough, the concept of the latent image. A very brief exposure to light creates an invisible but recoverable image in the silver iodide, which mercury vapor then makes visible when it's exposed. This means that the exposure times would be reduced from hours or days to now minutes or seconds. Suddenly, the idea of functional portraiture was possible. As a side note, I find it very interesting that the discovery and creation of photography and how important it's been for the world mirrors another invention or another discovery that happened roughly 100 years later with the discovery of penicillin. And it's funny because it sort of happened the same way, basically with really sloppy lab work. The French government acquired the rights to the daguerreotype and announced it to the world on August 19, 1839, at a joint meeting of the Academy of Sciences and Academy of Fine Arts in Paris. The process was declared a gift to the world, given away freely everywhere, except Britain, where it was patented. The response was immediate and global. Within weeks, daguerreotype kits were being sold across Europe and the United States. Within months, portrait studios were opening in major cities. The painter, Paul Delaroche, declared, "From today, painting is dead," a claim that turned out to be both wrong and revealing. So, pull out those notebooks, everybody. Let's take a few minutes and think about what Delaroche meant. Was painting actually threatened by photography? And what does his reaction tell us about how people understood photography in 1839? Was it an artistic medium, or was it a scientific tool, or something entirely else? Take a few moments and jot down your ideas.
On Monday afternoon, August 19, 1839, the French Academy of Science held a special meeting to publicly disclose the formula for making daguerreotypes. The technique's inventor, Louis-Jacques Daguerre, had sold his formula to the French government so that it could be made freely available to the public without patent restrictions. The new medium seized the public's imagination. Daguerreotype mania swept through Paris and across Europe. All who saw daguerreotypes for the first time were equally impressed. Viewers took them to be completely faithful depictions of nature. As quickly as railroads and steamships could travel, news of the invention spread around the world. Nowhere was the daguerreotype more popular than in America, a young democracy and a mecca of progress. The daguerreotype studio attracted a wide cross-section of Americans. People from all walks of life could now afford to have their portraits made, and they did. For all their popularity, producing daguerreotypes was a labor-intensive process, requiring a lot of equipment and skill. The daguerreotype plate is made of copper, faced with silver. To secure it and make it easier to handle, the plate is placed silver side up on an adjustable block. In order to prepare the plate for exposure, it has to be polished. In this modern demonstration of the daguerreotype process, the daguerreotypist applies a small amount of white powder, called rottenstone, to a cloth moistened with dilute alcohol. The daguerreotypist applies the alcohol and rottenstone to the surface of the plate using a consistent motion. The daguerreotypist sprinkles a fine red powder known as rouge onto a long padded stick. The plate is then buffed using the rouge. Polishing the plate in the same direction improves viewing of the highly reflective surface. The plate is then buffed a second time with a clean padded stick in order to increase its reflectivity. It is now ready to be made light sensitive. In the dark, the daguerreotypist places the polished plate face down in a sensitizing box, which contains a small amount of iodine crystals. In about 15 to 45 seconds, fumes from the iodine react with the silver, coating the plate with silver iodide. This process would then be repeated with fumes from bromine or quickstuff. From the sensitizing box, the daguerreotypist removes the plate, now coated with bromoiodide of silver. The plate is now light sensitive and ready for use in the camera. The daguerreotypist places the light sensitive plate in a plate holder with the coated side down. It is then secured into place. The viewing glass is lifted out of the camera and replaced with the loaded plate holder. The dark slide is removed to make the plate accessible for the exposure. To make the exposure, the daguerreotypist removes the lens cap. Early exposure times were notoriously long and sometimes uncomfortable, often taking more than 20 seconds. To ensure that the sitter did not move during the exposure, an 1840 Boston newspaper recommended the following.
His head should be placed on a semicircle of iron fitted to the back of the chair. His arms may be arranged at pleasure. He should fix his eyes on some well-defined object in any direction which he may prefer. Now, if everything is arranged as it should be, your portrait will often be made even in less than 20 seconds and in the most satisfactory manner.
In the dark, the daguerreotypist develops the plate. A few ounces of liquid mercury are very carefully poured into a flaring iron vessel, heated by an alcohol lamp. The exposed plate is removed from the plate holder and placed face down in the mercury chamber, which is heated to approximately 175 degrees Fahrenheit. After mercury vapor reacts with the sensitized silver, the daguerreotypist removes the developed plate. The daguerreotypist then fixes the plate, making it safe for viewing in normal light by pouring on it a solution of hyposulfite of soda. This removes the excess bromoiodide of silver not acted upon by light in the camera. After it has been thoroughly washed, a gilding stand is used to finish the plate. A weak solution of chloride of gold is gently heated over an alcohol lamp. This hardens the plate and adds to the beauty and permanence of the image. After a final cleaning of the plate, the daguerreotype is assembled for safekeeping and display. The plate is put into a shallow hinged case that includes a decorative mat and preserver, both of brass, and a glass cover with taped edges. Daguerreotype studios presented their wares in a variety of cases, ranging from simple leather or cloth-covered wood to elaborate examples of inlaid mother-of-pearl and molded thermoplastic. Their assembly was an example of industrial-age production. The work was often done by women and children, as in this factory, one of the largest of its kind. It is estimated that by the mid-1850s, in the United States alone, approximately 3 million daguerreotypes were produced annually, representing a retail industry of $7.5 million. In 1849, an American author concluded,
In our great cities, a daguerreotypist is to be found in almost every square. It is hard to find the man who has not shadowy faces of his wife and his children done up in morocco and velvet among his household treasures.
So the daguerreotype process, step by step, started by using a silver-coated copper plate polished to a mirror finish. The plate is then fumed with iodine vapor, which creates a light-sensitive silver iodine layer. The plate is exposed in camera from anywhere from 30 seconds to several minutes in bright sunlight. The plate was developed over a heated mercury vapor, and with that the image became visible. After the image became visible, the plate was fixed with sodium sulfothylate, and that removed the remaining silver iodide. Finally, it was rinsed, dried, sealed under glass. It being extremely fragile, it could not be touched. It is important for you to understand that a daguerreotype is not just an image. It's an object. Its physical qualities shaped how it was experienced. A daguerreotype is unique. There is only one. It cannot be reproduced directly. This gives it the status of a precious object, like a painting or a relic. The daguerreotype is mirror-like. Its highly polished silver surface means that the image must be tilted to be seen properly. Otherwise, you just see your own reflection. The boundary between viewer and image is strangely fluid. The daguerreotype is very delicate. The image layer on the surface of the plate can be destroyed by touch. Most surviving daguerreotypes are sealed under glass in protective cases. And the other thing about the daguerreotype is its intimate scale. Most of them are small. The standard sizes had names. Whole plates, which were 6 by 5 by 8 by 5 inches, half plate, quarter plate, and the tiny sixth plate. They were held in the hand like a locket or a mirror.
Today, only a handful of specialists create daguerreotypes. Here, Dr. Mike Robinson makes a portrait using his own version of the technique. A daguerreotype starts with a silver-coated copper plate, which is buffed for a few minutes to produce a mirror-like surface. The plate is placed face down into boxes filled with iodine and then bromide, which react with the silver to make the plate sensitive to light. After a few minutes, the plate is removed and any specks of dust are blown away. The sensitized plate is slotted into a holder for a camera. Setting up the camera for a portrait takes time. Working under a black cloth makes it easier to see the subject through the lens to focus the image. The sitter must remain completely still while the daguerreotype is made, or the image will be blurry. Once the focus is set, the wooden holder containing the plate is loaded into the camera. The photograph is taken by removing the lens cap to let light in. Exposures can take between 5 and 60 seconds. When enough time has passed, the lens cap is put back on to stop the exposure. The plate, still inside its holder, is now taken out of the camera. At this point, the image is still invisible or latent. To start the developing process and bring out the image, the plate is exposed to mercury fumes in another safe, purpose-built box. The developed plate is removed from the box. It now needs to be fixed to prevent the image from disappearing. Fixing the image with a type of salt, sodium thiosulfate, washes away any remaining light-sensitive silver, stopping it from reacting with daylight. Once all the silver has dissolved, the plate is rinsed with distilled water to remove the fixing solution. Next, to improve the stability and contrast of the daguerreotype, a solution of gold chloride is mixed and poured over the plate. The plate is heated to warm the solution and bring out the different tones in the image. A final rinse washes off any excess gold chloride. Lastly, the plate is heated again to dry it.
The daguerreotype democratized portraiture, partially. A painted portrait in the 1840s might cost the equivalent of several months' wages for a working-class person. A daguerreotype, however, by the 1840s cost far less and could be obtained in under an hour. But it also had its limits. Exposure times required subjects to sit still for 30 seconds to several minutes. Special headrests and posing chairs were invented and used to prevent blur. Children were difficult to photograph, and the daguerreotype was still too expensive for the very poor. Portrait studios opened rapidly in every major American and European city from 1840 onwards. And this image here that you see on the slide is of author Harry Beecher Stowe, taken in the 1850s. Another social impact that the daguerreotype held happened within the African American community. African American daguerreotypists were active from early on in the process's adoption. The daguerreotype created a new professional space with less established racial gatekeeping than older art trades did. There are a number of noted daguerreotype photographers who were African American. The image here, titled Untitled, A Woman Holding a Cased Image, was taken by G.J. Goodrich in 1851 or possibly later. Goodrich, the son of a former slave, opened his first photo studio at the age of 18 in Pennsylvania in 1847. Today, many of his works are represented in the Smithsonian Institute. Postmortem photography became common as well. Photographing the recently deceased was a way to preserve a likeness that might otherwise be lost. And at that time, death was looked at a lot differently than it is now. Here, death is sort of hidden away. People get sick and go to the hospital. They pass away, and the next time you see them is maybe at their funeral, sometimes not even then, if they don't have a viewing. But back in the olden days, death was more in your face and more apparent. And because of the nature of photography, it allowed you to have one more picture of that person. Somebody might not have ever had a picture taken of themselves or a family photo. And once somebody passed on, that gave a chance for one last ability to have a picture of everybody together. So it became in vogue to actually dress the person who had been deceased up in their best clothing, and then either take pictures of them laying in state or sometimes posed with the family. Many times they would leave their eyes closed, but sometimes they'd actually open their eyes as well. A lot of the Victorian type photography that you look at these days, doing searches online, a lot of it is postmortem photography, but it's hard to identify because a lot of times you can't tell who is actually alive and who is the person that's passed on in the photo. Another reason that it happened and was very, I don't want to say popular is not the right word, but it happened a lot, was pictures of infants who had passed away or children who had passed away. Infant mortality and child mortality was so high back in those days, and you may not have ever had a picture of your child. So it was the last chance to have a physical proof, physical item that showed that child existed, to show that person existed. And that's why it became so prevalent. Scientific applications followed quickly soon afterwards. Images of the moon, solar eclipses, and microscopic specimens were among the first non-portrait subjects, and because of the reduced exposure time, they were finally possible to be made. Here, we have William Henry Fox Talbot. Now, William Henry Fox Talbot was a British polymath, a mathematician, linguist, and a member of Parliament who also pursued scientific research in optics and chemistry. According to his own account, his inspiration came from frustration. While trying to sketch the Italian landscape with a camera lucida in 1833, he was struck by how inadequate his drawings were, and he began thinking about whether it might be possible to make the optical image fix itself. Talbot began experimenting with what he termed photogenic drawings, cameraless contact prints made by placing objects on silver chloride paper and exposing them to sunlight. These are among the earliest surviving photographic images. The one here on the slide is called Photogenic Drawing of Lace, which was created in 1839. Here is a close-up of the last image that I just showed. I enlarged it and I messed with the contrast and exposure so that the lace that was used for this photogenic drawing could be more apparent and easier for you to see. Notice at the bottom right of the image, it has been signed by the photographer himself, H.F. Talbot. And this is similar to a cyanotype, where they had where Anna Atkins and the people who practiced cyanotype had placed algae in her case, but also flowers or items onto the treated paper and exposed it to sun. However, this wasn't using the same kind of chemistry that the cyanotype did. Talbot's key breakthrough came in 1840 when he discovered that paper coated with silver iodide could be briefly exposed in the camera, then chemically developed to reveal the latent image. The same latent image principle that Daguerre had discovered arrived at independently. Talbot named this process the calotype, from the Greek kalos, meaning beautiful, and he patented it in 1841.
William Henry Fox Talbot revolutionized photography in Britain. He invented the first photographic negative process, which became the basis of virtually all photography that followed. Talbot was an expert in many fields, including chemistry and optics, the study of light and lenses. But Talbot could not master drawing. Instead, he looked to science for an alternative way to capture what he could see. In 1834, he began to experiment with ways to make and fix images using light and chemistry. Scientists already knew that silver, when combined with salts, was sensitive to light. With this in mind, Talbot coated paper in a solution of table salt, then a solution of silver nitrate, to make it light sensitive. This combination of chemicals caused the paper to darken in sunlight. To make an image, Talbot placed an object, like a leaf, on top of the sensitized paper and left it in the sun. The object blocked out the light, stopping the area underneath from darkening. This left a reverse impression of the object on the paper. The resulting images were known as photogenic drawings and became the first photographic negatives ever produced. Talbot went on to experiment with the process using homemade cameras. When he placed sensitized paper inside one of these, light reflecting off a subject traveled into the camera, making an image on the paper inside. Like photogenic drawings, the paper registered areas of light and dark in reverse, creating a negative. When Talbot placed one of these negatives onto another sheet of sensitized paper and exposed them to the sun together, the dark areas of the negative blocked out the sunlight, while the white areas allowed the light to pass through. This created a positive print. With this, Talbot had invented the groundbreaking negative to positive process. For the first time, multiple prints could be made from a single negative, which could be used again and again. Talbot patented his process in 1841 with the name calotype, which means beautiful impression in Greek. Talbot's invention of the negative to positive process led the way for photographers until digital technology arrived. Rob Douglas is a specialist in making calotypes. The first stage involves preparing the negative under red light. A light-sensitive solution is mixed. Its active ingredient is silver nitrate, which darkens when exposed to light. Drops of a weak acid solution are added to balance out the effects of the silver nitrate and keep light areas light. The sensitizer is applied to paper, which is placed inside a wooden holder for a camera. The camera is loaded, and the lens cap is removed to let light in and expose the paper negative inside. Because of the way light travels, the image appears upside down on the camera's viewing screen. In bright sunshine, it takes around 3 minutes to capture the image. But at this stage, it is not visible. In the darkroom, developer is prepared to bring out this latent image. The timer is set, the developer is applied, and the negative begins to appear. The key developing ingredient is gallic acid, which speeds up the reaction of light with the silver solution on the paper to reveal the image. Once the negative is dark enough, the paper is submerged in a solution to wash away any remaining silver and fix it. To make a positive print, another piece of sensitized paper is placed onto the negative in a printing frame. The frame is flipped over, taken outside, and exposed to light. Sunlight passes through the light areas of the negative, turning those areas of the paper underneath dark. It can take anything between 5 minutes and a few hours to create the positive image, depending on the strength of the sunlight.
So the step-by-step calotype process was, first off, brushing a paper with silver nitrate, drying it, and then brushing it with potassium iodide. That creates silver iodide. That was then sensitized with gallic acid and silver nitrate before use. After a brief exposure in camera, from 30 seconds to several minutes, it would create a latent image on that sensitized paper. Development of it was with gallic acid, and after that the image would become visible. In order to have the image stay, the image would need to be fixed with sodium thiosulfate. After that, the image was made permanent. And the result was a paper negative with reverse tones. Unlike a daguerreotype, which gives you those positive images, it would be a negative. And so in order to make a positive print, you would need to use the same kind of sensitized paper that you used to make the negative, place it on top or underneath the negative, and then you would expose light to it, then turning the negative into a positive on the new paper. Now please, if you're not using your notebooks, grab them now, because this is so important. The crucial innovation, the negative-positive process. This is the single most important technical concept in this section, and one of the most important in all of photography's history. So with these key concepts, Talbot's calotype produced a negative, a paper image with reverse tones, where light areas appear dark and dark areas appear light. From this one negative, you could produce many positive prints by contact printing. This is the foundational logic of all analog photography. The negative-positive process is what makes photography a medium of mass reproduction rather than a maker of unique objects. The daguerreotype was beautiful and precise, but it was a dead end. The calotype was the future, even though it lost commercially in the 1840s. Here's a small comparison chart that I created that shows the differences and the similarities between the daguerreotype and the calotype. The backing, the support for it, for the daguerreotype was a silver-coated copper plate, whereas calotype was paper. The daguerreotype was not reproducible. It was one unique image, and that was it. Whereas the calotype, you can make unlimited prints from one negative. The detail of the daguerreotype was extremely fine-grained. It was very, very sharp and precise, whereas the calotype was softer. You could see the texture of the paper visible through the image. As far as exposure goes for both, they were very similar, from 30 seconds to a few minutes, but they were variable depending on the amount of light and where you were at photographing. The cost for daguerreotype was much higher because you had to have polished metal plates, whereas calotypes was lower because it was just paper and chemicals you were purchasing. And the legacy for both, daguerreotype was a dead end. Because there was no negative and the image was one and done, that was it. Again, the idea of it being a unique relic or an item as opposed to something that could be mass produced for people. And that's where the calotype won out, because it ended up becoming the foundation for all of analog photography. David Octavius Hill, who was a painter, and Robert Adamson, who was a photographer, created a partnership that was active from 1843 to around 1847. Hill originally commissioned the photographs from Adamson to help him paint a large group portrait of the founding members of the Free Church of Scotland. What they instead produced was one of the great bodies of early photographic portraiture. In the image you see on this slide, they were making a portrait of Reverend Thomas Chalmers, one of the founding members of the Free Church of Scotland. The calotypes they created of the Free Church of Scotland and its founding members, of the Edinburgh fishwives, street scenes, and formal portraits are all characterized by their warm tonality and soft atmospheric quality, as well as their evident sympathy for the subjects. The paper grain that Talbot saw as a limitation and was not a fan of became, in their hands, part of the aesthetic. These images are among the first made by photographers to treat the medium as an art rather than just documentation. Look at the differences between the calotype on the left and the daguerreotype on the right. Where the calotype has a softer, warmer look, the daguerreotype features a crisp sharpness. Because of the nature of the daguerreotype image, the extreme sharpness of it is hard to photograph. Even so, you can see the differences between these two very different processes that still use the same ideas of creating a latent image that is then brought out through chemistry. So here's some more key terms for you. I'm going to go ahead and take a look at these, from daguerreotype to latent image, calotype, photogenic drawing, and keep those in your notebook because, again, we will be falling back on these terms as we go through the semester. And now, for the moment I'm sure you all have been waiting for, the first assignments for our first week of History of Photography. So our first assignment we're going to talk about is our journal discussion number 1. And with that, what the prompt is for you is, whose vision of photography feels most relevant today? Was it Daguerre's, which is a unique, spectacular object, or was it Talbot's, something that was reproducible and shareable? So with this, what you'll need to do is go into the discussion tab through Canvas, and you'll see the question posted. You'll need to write something between 150 and 200 words where you're taking aside using at least one specific image or detail from the textbook. Once you write that, you will go ahead and hit submit. You have to make sure you do it, though, by 11:59 p.m. on this upcoming Thursday. If you are later than that, you will end up losing points. And after 3 days, you'll get a 0 on it. So make sure to do that. It's just 150 to 200 words, paragraph or 2 should be just okay. But you do need to support your argument on your side and use at least one specific image or detail from the book. You'll also reply to 2 classmates' posts each week. So that one will have to be done before 11:59 on that following Sunday. So if you're seeing this on the first Sunday, you want to make sure that you put your post in by Thursday, and then if you're able to, make a reply before 11:59 for the following Sunday. And please make sure that your replies, that you either agree or disagree with your classmate's argument and explain specifically why or why not. Maybe ask a genuine question that pushes their thinking further. Just saying, hey, great post, or thumbs up, that doesn't earn full credit. And the other assignment that's due before 11:59 this next following Sunday is for the reading response. And so with a reading response, in 300 to 400 words, I want you to compare the daguerreotype and the calotype. So when you're comparing these two, I want you to address three things. Number one, how did each process shape what could be photographed? Number two, who could access the medium and who couldn't? And number three, what kind of future did each process imply for photography? Please use specific examples from chapter 2 and 3, and don't just describe the technical differences. Think about how those differences and what those differences meant socially and culturally. Both of the last one that was on the slide, the journal discussion, and this are all done via Canvas. You'll see the assignments waiting for you. I have all the due dates programmed in already, so please make sure to take those through there and submit. If you have any questions, please feel free to reach out to me, again, through my email at bruced@flc.losrios.edu, or you can contact me on Canvas as well through the Canvas inbox. So, wrapping up with the first of our lectures for History of Photography this semester, I want to go over just a real quick short list of what we covered. Again, this is not an exhaustive list. It's not everything that you'll need to know. For that, you do need to do the readings. So the readings for this week were Chapter 1, Chapter 2, and Chapter 3 in Seizing the Light. So please make sure to do those so you get a full picture of what we spoke about. But what we covered on our short list was why photography was demanded before it was invented. And the term that we used for that was Hirsch's modernity framework. Now, that's what the author Hirsch had sort of thrown out there as a theory. We spoke about the camera obscura, how a camera obscura works, what it is, and the problem of the permanence or lack of permanence in the images. We talked about Niepce, Daguerre, and Talbot, the three different answers to the same problem. That problem being how to make one of these images coming from a camera obscura, how to make it permanent. And they all happen to be working roughly at the same time in three very drastically different ways to find the problems to the same, or find the answer to the same problems. And then we talked about the daguerreotype as a unique precious object versus the calotype, which is the foundation of mass reproduction and sort of the base of what we ended up having for analog photography. For next week, for week 2, we're going to be moving on in the readings, of course. We're going to be speaking about what plate collodion, the Civil War, and the portrait studio boom. So we'll get into that next week. Until then, make sure you read Hirsch chapter 4, 5th, and 6th. Again, it's Seizing the Light. Chapters 4, 5th, and 6th. And getting a jump start on that will really help you out with mastering the information that we'll be having next week. Again, if you have any questions, please feel free to reach out anytime. You can email me at bruced@flc.losrios.edu, or you can also message me through the left-hand side, that side for you guys, that side, hopefully, on the sidebar in Canvas under Canvas inbox. You can send me a message directly there. Again, thanks a lot, and I look forward to seeing what you guys write this week. Bye-bye.